how hard is it if somebody would come along, another company would come along, similar to Space Adventures, and want to do something with ISS that way?
In terms of flying people?
Yeah. And where's the limitation? Because there is some sort of, we step all the way back, this goes, this does not, this, that kind of thing.
Well, my office, we only deal with payloads.
Okay.
So we don't handle like commercial crew and all of that. That's being handled out of a different office. So I guess if a commercial entity wanted to fly their own people up to the station, they would probably want to talk to people. Right now, I guess the place to start would be the transportation office. And then once the commercial crew office gets stood up, I think those would probably be the people to talk to.
What about, what's the kind of, for payload stuff, what's the kind of, foreign of this is where, you're not going to go here with whatever your payload is, kind of, is there
well, in the National Lab Office, we're trying really hard to follow the mantra that if you can meet the interface requirements in terms of just safety, off-gassing, as long as you can show that you are safe to operate within the station, it's not our place to judge the value of your experiment or your hardware, even whether you're going to work or not. That's your investment, that's your buy-in, and we're trying to not get in the way of that.
What's the chat room going?
I'm still trying to get on it right now, so.
We'll give people another minute or so.
I started the recording since we're so far in already.
Okay.
So 20 minutes in.
Yeah.
Well, theoretically, there's still people coming in, I'm sure.
Yeah. All right, well, I guess we'll go ahead and get started then. Yes. If people trickle in, they can join in. Like I was explaining to Aaron, my name is Justin Hugler. I work in the ISS National Laboratory Office in Johnson Space Center in Houston, Texas. And the talk that I wanted to have today in this forum was to get people's ideas on what are different ways that we can use the space station from what we've traditionally done. Up till this point, I think the ISS has been largely viewed through two lenses. There's just the exercise of actually building and operating it, which has taken up the vast majority of our time up till now. And now that assembly is largely complete, we're starting to get the kind of traditional microgravity science that has been in the pipeline for years. That's starting to get done. And we're starting to see some of the results from that. But through the National Lab Office, we have this unused capability that we can put to use. And the National Lab Office has been chartered by Congress to essentially help other government agencies, private industry, and educational institutions take advantage of that. So at the space station, you get the microgravity environment, you get power supply, if you can operate robotically, we can take you in and out of the airlock on the Japanese module and stick you outside temporarily if you need that. And so the idea is that we've got all of these resources that are available up there. So what would you do with it if you could get up there? What would you want to do if you could get up to the space station?
I guess the thing isn't what do I want to do personally? I guess the thing is, what do we as a race want to do with the space station eventually? I mean, in like 1980s, we were dreaming about making a space station as a jump point, say, for Mars.
Even earlier than that, if you look back at von Braun's original paradigm from the 40s on, you see at where we are now, we're actually in the second step of his idea. His idea was that we would go from suborbital flights, like we did with Mercury, to orbital flights, like we did with Gemini to, and in his view, actually the way to go was to go from suborbital and orbital capsules to a space shuttle, to a space station, to manned exploration of the moon and Mars. And the moonshot actually kind of short-circuited that plan in a way because it focused all of the resources on getting humans on the moon as quickly as possible. And then once that was done, NASA essentially tried to realign itself to get back on the path that von Braun had set out on all those many years ago. So that's why you saw in the late 70s and early 80s, we built and flew the station. And then once we had, the shuttle, and then once we had the shuttle, we used that to build the stations. Very much a continuation of paradigms that had been theorized back in the 40s and 50s. But I think now we're in a situation where enough time has passed and enough circumstances have changed that we're starting to realize that we can't just keep following the von Braun paradigm anymore. We've got to figure out a way to conduct space exploration and space utilization in a way that's more relevant to the interests of people here on the ground, because even with the slight plus-ups in the budget that Congress has indicated that they're willing to live with, it's still not a whole lot of
Still less than 1%.
If you go back, well, if you mind me, it's to a certain degree, if you go back to the old von Braun paradigm, that was built around the budget level in many respects of what they were getting during Apollo. And, well, not really Apollo, but Gemini, Mercury, Gemini, and the very first Apollos.
Right.
And
they thought they were going to get to keep that.
No.
Not so much.
No, not so much anymore.
So and so that's why it's interesting. I've heard people say that we're in a unique situation with station, and certainly we never want to repeat this aspect of it, but we have a chance to learn a lot actually this way, and that is when we have built something we have no idea how to, or we don't. It's not that we don't have any idea, but we haven't allocated the funding really to utilize it, and and so this is a chance to kind of learn how to do that. I think
And so that's why we're in terms of getting something up to the space station, especially once we get the cargo resupply flights going with Orbital and SpaceX, we can get things up to the space station, even after shuttle retires. And with the SpaceX Cygnus vehicle, we do actually have return allocated for the rest of Dragon capsule, we do actually have return capability. We can bring samples back down. So given that we have this capability and that Congress has said they want it to keep flying at least till 2020, and what we're looking at is probably outwards of 2028 or even further if we can keep the hardware certified that long. We have this resource. How do you want to use it? How can we open up the space station in a way that is relevant to what people down here on the ground, especially even though it is an international space station, the National Lab, we're focused on American interests and American companies and technology. So we want to figure out ways of helping make what we do on the station have more value to Americans. So what kinds of things would y'all like to see us doing on the station that we're not doing right now?
Does that exclude, it seems like one of the biggest benefits to stuff on the station you can do is to do whatever it takes to get us to Mars, or otherwise, further the goals of the human race, which is, off-site backup kind of thing. Now, does that exclude? That's not really America. That's more of, planning.
Yeah,
is that outside the scope?
In terms of the National Lab Office, they're definitely encouraging people to have partners, but there does need to be some kind of direct connection to a U.S. entity. For example, the alpha magnetic spectrometer that's going to fly up to the station on the last scheduled shuttle flight. That's considered a national lab payload because even though it has all of the international cooperation and collaboration involved, it's sponsored by the Department of Energy.
Mm-hmm.
So AMS is coming through as one of our payloads. And for example, NanoRacks, to mention them again, we know that they're in discussions with international customers to fly international commercial investigations, but because it's NanoRacks hardware and NanoRacks is doing the integration, it comes through the national lab.
What commercial? I know there's NanoRacks. What are the other full, almost entirely commercial payloads that are going through national labs right now? Or are they the only ones who have a full commercial aspect to them?
They've kind of been our pathfinders, helping us figure out what some of the best mechanisms are, but we actually have, show you all. So we've actually signed deals with a number of companies. For example, we're working with Ad Astra Rocket Company, founded by former astronaut Franklin Chang Diaz, and he's trying to commercially develop plasma rocket propulsion. And so we've been talking with him about possibly flying a plasma rocket demonstrator on the ISS.
Yes.
We work with a company called Astrogenetics, and they take advantage of the microgravity conditions to do genetic research because...
They're the old SpaceUp company?
Yes, old SpaceUp company. Same thing with BioSurf Space Technologies. They're doing research on vaccines and cellular biology on orbit for commercial customers. Much the same kind of research is going on with ZGI and NanoRacks. We've also worked with Walt Disney and Pixar on the Buzz Lightyear on the space station project. So they actually flew a Buzz doll on the space station for a year. And
I remember hearing about him coming home.
The astronauts filmed activities that they did on orbit, and then we helped Disney and Pixar figure out what video shots were good, what their educational content would be, and they actually have put together a series of videos. Essentially, they call them Buzz Lightyear mission logs of his experience on orbit, and those are going to be They've been the first two were packaged with the Toy Story 1 and Toy Story 2 re-releases on Blu-ray, and then when Toy Story 3 comes out on Blu-ray, the third mission log will come out with that. We've also partnered with Microsoft to do various educational challenges. We actually work with AMSAT on some of their projects. I work more on the technical side, the implementation side, but I know that our business folks are also working they've put out a series of broad area agreements and standing announcements of opportunity to bring in more commercial partners, and I think there will be some results announced from that soon.
What about astronaut time?
We get an allocation of astronaut time. So people that come through the National Lab Office, essentially the way it's been working thus far is they put forward their resources to get their payload developed and built, and then we help them get on orbit, and they get a part of our on-orbit resources that are allocated.
kind of wondering what there is to do up there. I mean, what would you stuff up there? That's interesting with the genetic research and stuff like that. That's definitely got applications, but.
Well, for example, the reason why the microbiology people are really interested in microgravity is because they found that virulence increases on orbit. There's something about the presence of gravity that actually suppresses some of the processes. So if you remove one, this is essentially all science, all engineering, all knowledge that we've developed on the ground has a 1G acceleration imposed on it. That's the one factor you can't remove here on the ground. And by being able to do long duration examinations in microgravity, you can remove the physical processes that are driven by gravity, such as stratification, solidification, buoyancy, things like that. And you can look at more fundamental processes that are masked in the presence of gravity. So fluid physicists are really interested in assays on the space station. I know NanoRacks has actually developed partnerships with, I think, some of the biotech and pharmaceutical companies. Let's see.
I mean, there's a lot. There's actually a number of interesting ones I know of. I was kind of interested to see what other ones are out there. Because like, I know like AstraZeneca, they're actually starting phase trials for a drug they developed for Lake salmonella.
Yeah.
Vis-a-vis space shuttle and space station flights. And actually they're starting work on another one for what the other drug is. They're starting another one that they hope to carry through trials and so forth. I know, and
for example, one of the things that we've been working with BioServe on, they went to fly cells from the Jatropha plant on orbit. And Jatropha is interesting because it's a potential source for biofuels. And so they want to see if they can take advantage of microgravity to better isolate the genetic components that drive the oil production, so they can figure out how to better breed the different strains of the plant on the ground and essentially know what to look for in their stock plants.
And I know there's some other stuff related to, there's interest. I don't know if there's how far that's going, because related to substrate production. There's some other interest related to stem cell production. I don't know if anything's come from that yet, because there was a lot of people doing that while when they were putting the station together, that ruining the experiment, because you need something that's that is very stable. That's not, right. It doesn't have a lot of jostling.
Right, and now that assembly is largely complete, and we do have the active rack isolation system on orbit, the environment is typically fairly quiescent.
So you're actually working on this NanoRacks, is that called?
They are one of the companies that my office has sponsored to fly on the station.
Gotcha.
And then another one of the benefits of the station is, by virtue of its relatively high inclination orbit, it views 95% of the populated landmass in a given day. So, for example, through the Crew Earth Observations Program, we've been able to get crew imagery to track land use for city planning in India. Whenever there's a volcanic event, we can actually it's actually sometimes faster to get the crew to take pictures than to task a satellite to get over there.
Huh.
Well, and one of the advantages of having the crew do it is, if you're tasking a satellite to go over there, it pretty much takes a pass. You look at the data. If it's not what you're looking for, you have to retask it. and that can be somewhat tedious, especially if you're competing for time on a commercial satellite. Whereas having that human brain in the loop, if they see something that's interesting or out of the ordinary, they can say, "Oh, what's that?" and on the fly repoint the camera and take pictures of it. So
If you got a secondary eruption or something like that.
right. So our Crew Earth observations program folks, they actually do a lot of work on, like I said, land use, city planning. They look at deforestation, the changes in river deltas over time. I'm trying to think of some of the other projects that they've done. Light pollution, because they get some amazing nighttime imagery. There's one shot that they did of the Houston area at night, and it shows how developed the Houston area is, that you can actually see the shape of the coastline in Galveston Bay in the image. It's that densely populated. Let's see. They also do a lot of work on taking imagery of Earth analogs for geological formations that are seen on Mars and other planetary bodies. So they'll take pictures of hard to detect crater remnants and things like that. What would you do with the station if you could get something on board?
What I would like to do is have floating cameras for EVA work, so that you can get close-up views in high def, but from any position that was best for the view.
And the open space thing?
Where's the open space thing?
I think that's in the next one over.
And and I know there was some work with those spheres used aboard inside the station.
Yeah, that's
Yeah,
one.
we talked
That's
about
one of the.
that a while ago.
That's
as
one of
well.
the
I
payloads that
remember
responds.
seeing it on the website.
I mean, I had this idea years ago, and then I heard, oh, somebody's actually working on this, but nothing's ever happened in terms of actually putting one outside and flying it, information with the station and some EVA. I'm terrified of the risk, but
Internally, matter of fact, we did a spheres run for the NASA Summer of Innovation program just last week, where we actually, through MIT, student groups from around the country actually competed and raced the Spheres satellites through a virtual obstacle course. And the teams that had essentially
I don't recall.
the teams that had the best algorithms won.
cool.
So-
I do remember seeing the spheres deployed on the station.
I've seen video
I
of
was
them.
watching it on Space Vidcast just
And
idly.
that's actually interesting, because that has actually recently transitioned from being a essentially Department of Defense experiment to a NASA facility. So we actually set up an agreement where NASA the Department of Defense gets half of the time on spheres to do DARPA-funded experiments, and then NASA will get the other half of the spheres time to do either NASA-based research, develop commercial research, and do educational programs. So Spheres has actually become an on-orbit facility
That's cool.
on the space station. And I know that DARPA has expressed an interest in doing what they call an exosphere, essentially a Generation 2 spheres that could fly in and out of the Japanese airlock.
That would actually be pretty helpful, especially spacewalks and type places that usually you wouldn't want to stick an astronaut's head in because it could be too dangerous or too hostile or too toxic or whatever.
And back in the 90s, JSC actually worked on something similar called Mini Air Cam. But that was another one of those projects that got canceled when funding for the station was cut back.
one thing I'm wondering about is the Buzz Lightyear launch.
Mhm.
That one, is what I'm wondering about is like, I mean, you know, there's the experiments and then there's education. Those kind of are the two quick and dirty ones. You know, what about something like putting on a suit, not taking something similar to what they do with Buzz Lightyear, but make it so that you have, you know, have stuff so that it's something that's interacting all the time, and it's not just about education. I mean, this probably isn't practical to do it on a full scale on station, but something like, you know, if you could put up a series of like laser tag things in the station that would move around and try and as an on-orbit video game for people to interact with.
Or as a special sphere that users at home could interact with, as maybe part of a PE program.
You know, something like that would be really cool. You could design the thing to have a safe operating envelope that no user could ever fly it past. And assuming you trusted its autonomous capabilities, you know, it would be wow, what a tool that would be.
You know, like a 3D space maze.
Well, I would think of something outside, you know.
Even outside, yeah, no, that'd be cool.
Well, outside would be very cool, but I was,
you could have the user pan that exosphere down, and you could.
When I was at
that
Berkeley,
user could actually see the curvature of the Earth.
They could see the curvature of the Earth. They could look at the station, you know, whatever.
So long as they don't look at the sun, I mean.
And again, you build that into the flight envelope or whatever it has. At Berkeley, I worked in this group that developed a very high resolution Pantiltzoom camera up over our sort of main quad area, and users could go to a website and there'd be a big panorama of everything that the camera could see, but you could select a rectangle and it would zoom in on that rectangle and let you see what it was. But no one user had control. It sort of chose among all the desired rectangles what to go look at. And you know, it was a reasonably successful experiment in sort of mass control of a single camera. And you could try doing something similar to that. You know, it's just from an engagement perspective, I've always thought that better video views of what's going on up there would be pretty cool. Now, you know, I know there's a bunch of other issues like the data rates involved in getting HD video down on a bunch of different channels at once, and
or maybe even just having a hard drive, well, not a hard drive, but a flash type device, and have it downlinked at the next convenient time would make sense as well. I mean, the user would still be able to control it, but it'd be a delayed sending of commands, and it would be a combination or a average.
You get the problem with some of that stuff is it's easy for people like us to get excited about that kind of stuff.
Yeah.
You know, and so we'll see it. We'll get ooh-ah and go head over heels. What's the thing that grabs, you know, somebody else, you know, somebody who's not a space geek? How do we get them interacting with it somehow?
That's one with a camera idea. What if you just do your zip code?
Well, I was thinking more along of it. That's why I was thinking like a 3D maze within the station. Like you have
or you could do both things. I don't see why you couldn't do both. I mean, you could have an interactive video game inside the station or whatever.
No, I'm looking for. I think the key thing is not to limit it to just, you know, an exterior camera looking at the Earth.
No, yeah, I know.
That's what I would. You know, what's the thing that you know says this is something new for me to try. You know, because to me another picture of the Earth is just another picture of the Earth. I'm sure that sounds terrible, but that's kind of my attitude at this point in time.
But I guess the real question is how many regular humans have seen the curvature of the Earth other than people that are really into space and really seek out that information?
How many people have seen that? You know,
well, not so much Earthwise.
Earthwise counts as Earthwise. It really does.
Oh, and there are actually a lot of people that credit the Earthwise photo with being the birth of the modern environmentalist movement, because that was the first time that we saw the full disk of the Earth.
And I guess we got to also remember that was 40 years ago. That's a good generation or two ago. There's kids like me and Noah that, you know, want to see this stuff other than through a like a military spacecraft or the space shuttle. We want to see it through a different perspective, I guess, you know.
Most of the experiments seem to be biological in nature, is that correct?
Up to this point, a lot of the work we've been doing has been with biotech companies.
Do you know about openpcr.org and biocurious.org? A couple of sort of open source movements. OpenPCR is an open source PCR platform. They use a thermoelectric cooler, you know, and they basically let you build a tiny little PCR machine and you can do your own genetic experiments. And I don't really know what kind of hardware BioCurious has developed, but it seems like maybe there's a potential there for, you know, open biotech in microgravity kind of a thing to do.
Yeah, well, you got something like Team Fred not trying to do the Google and Earthwise. Why couldn't you do something exactly like that? Take what you're talking about and expand that and do like what Team, you know, so you're doing an open bio thing.
Right.
Build with the goal of putting down the station and doing Experiment X or whatever.
Yeah, and you know, the thing that makes these things work is getting a lot of involvement, people involved, and it's hard to run lots of people's experiments on in a scenario like this, right? So if you could find a way to get 10 experiments packed into a single cube, you know.
I wish Jeff Mann was.
Yeah, that would be the purpose. Do you know NanoRacks or not?
Pardon me?
Do you know about NanoRacks or not really?
Only what I've heard a little bit about them before, and I didn't realize that it was Kentucky Space and a thing called NanoRacks. But I thought I saw a press release from NASA, in fact, saying they were going to have fixed CubeSat positions on the station for experiments.
We've got 2 racks on orbit right now.
Right.
And each one can hold up to 16U.
Are they populated yet?
The first test modules have been flown. We've got one that essentially just does system diagnostics, make sure everything is turned on the way it's supposed to. They've got a student experiment that is essentially testing the effects of the interior microgravity and radiation environment on the station on flash memory.
Oh, okay.
And they've got some other customers in the pipeline that we're going to be flying soon.
Now, what about flying a couple of CubeSats like that on MSL?
Mars Science Laboratory?
Yeah. Can MSL spare the power and payload for 3 or 4 kilograms worth of?
I don't know. That'd be something to talk to the SMD folks about, because I know my understanding is that SMD is controlling MSL access pretty tightly.
Yeah, I figured as much. It was just maybe not MSL, maybe some follow-on lander mission, but a way for, a student group to get on a planetary mission without.
There's interest in doing essentially a telerobotics demonstration from the ISS, where essentially the crew on the ISS would do a telerobotic operation of ground test versions of robots that could eventually be deployed on the moon or Mars. So maybe there's an opportunity there to get more public involvement.
You mentioned astronaut time internally and the astronaut time externally, or no astronaut, or not possible.
Getting EVA time is extremely difficult.
Okay.
As a matter of fact, from now on, we are asking, not even so much as asking, we're pretty much requiring future external payloads to be EVR, that's robotics compatible. We do not want them to be EVA dependent.
Because one thought, and you might be able to do this with robotics, I don't know, is utilizing, because you've got different Google and Earthwise teams and so forth. And one of the things we did I'm in engineering at University of Michigan, or our senior design trust would do, was the idea of doing a transit satellite to take payloads to and from basically various landers and so forth from the Earth to the Moon. And one thing I wondered, one idea that was batted around was the idea of having the lander modules come up in something like in a Cygnus or something like that, assuming it doesn't weigh too heavy, and then it would get transported onto this transit vehicle and go to the Moon. Do you think, assuming you had it was robotic interface, do you think something like that would be practical to do or not?
So essentially using the ISS as a
staging ground for Lunar Arch Prize competitors or whatever. That way, that way they don't have to buy a dedicated launch vehicle. I need to be able to put 50 pounds up to ISS. I need 50 pounds going on the Cygnus, and it's going to get me kind of effectively near it. And then you'd have the satellite come in that would also either dock or it would at least rendezvous with the station, and it could and the station could transfer the smaller payload to the
tug.
Yeah, exactly.
That's possible, I would imagine. Of course, then that also gets into the issue of the inclination of the ISS orbit, so there would be plane changes that the tug would have to make. But
assume that's the tug's problem, not ISS's problem.
But yeah, if there was a tug that essentially carried these landers to the Moon, as long as they could get right up to the station.
I mean, that way they wouldn't have to pay for a full-on rocket launch, because that's a lot more pricey.
So in other words, they could be treated as almost like an external payload, go up in the
Cygnus or all 8.
I don't think Cygnus has external payload. At least the Cygnus that we're paying for doesn't have external capability, but Dragon has a trunk for it.
Yeah, Dragon. Take your pick of whatever your up mass would be. You've got your like I'm going back to Team FredNet because I remember them. Their lander would come up on a Dragon. They're paying for 50 kilograms on that. That gets transferred over to a bus or a transit vehicle to the tug, and that way they don't have to. They don't have to worry about that last leg of the journey. They don't have to worry about so.
The way they don't have to be the primary payload.
Yeah.
Okay.
Can ISS crews not deploy a cube satellite to be free floating, just with that initial impulse away from the station?
It's been done before, but
suit set and things like that.
Yeah, but the safety requirements that are in the safety reviews that go into a hand deployed payload can be a real pain.
Okay.
And so a lot of our PDs.
Is there an actual risk of just collision with the structure on the way out? Is that what
you have to do collision avoidance analysis. You have to remove all sharp edges because they don't want to. All sharp edges, all sharp corners have to be dealt with because they don't want you to risk a suit tear.
Right, but if it were done like out of a P-pod launcher, for example, where let's say they pack 3 satellites in the traditional 3U launcher inside, without wearing a suit, and then all they have to do is like bring this thing or position it in an airlock and spring it open and just let that little spring impulse let it go. It seems like
there are people that I have heard that idea bandied around before, but then that also gets in the idea of having essentially a loaded projectile launcher inside the internal volume of the station.
I'm sure they've got equivalent sort of energy. I don't know. I'm just.
And so I wouldn't say it's impossible, but it's also it's largely a matter of when you start getting the crew involved, the level of complexity in terms of your operations and your planning goes up tremendously. So that's just something that you
Well,
have to.
and I don't even know if it's worth it, but to first bring, preloaded P-pods up to station and then have them deploy them versus deploying them off of some other launch like is currently done typically. I don't know if it makes any sense at all. It was just a thought.
Well, the plan that we have right now for doing deployables is that on SpaceX launches where we're already flying an external payload in the trunk, they're going to put in essentially an extender that gives them just enough room to put a couple of P-pod launchers and a couple of CubeSat launchers. So that way the P-pods and the CubeSats will deploy off of the second stage,
Mm-hmm.
and they won't actually come to station, but they're taking advantage of the fact that we've already got that launch opportunity.
That's great.
And by doing it that way, since those P-pods and CubeSats don't directly interact with station, they're able to avoid a lot of the human rating requirements that they would otherwise have to impose on themselves.
And that will almost make it more sensible to do that. Yeah, okay. I mean, the only thing I can imagine is maybe it's easier to pack more CubeSats in a fashion that's not deployable automatically, but be deployable after some human hands got to rearrange them, that kind of a thing. And so.
Yeah, but EVAs come at a premium.
Yeah, I'm not even really suggesting an EVA so much as is it possible to create a launching mechanism that can be operated from inside the station? In other words, something that
you can load it inside the station and then
you load it up inside the station. You get the set ready. You erect the launcher in the vestibule or in the airlock. And you get out, and then you just open the exterior door. I guess you have to have a person in there, don't you, to open that exterior hatch?
Yeah.
So okay. So there's not a way to avoid that, but that was kind of my thinking was and then even then it's definitely an EVA because they've got to prep and do the camp out.
Yeah.
No.
Unless you're going to produce a new module or a new thing to stick on an airlock that would be designed to those requirements.
The problem is opening the exterior door.
Well, that's it. You wouldn't have an exterior door. You would build an airlock component to those requirements.
The only way you could do that without having to have the crew prep for an EVA is if you somehow deployed it out of the gem airlock.
Right. Oh, that's right. That one does exist. So,
but
what's their path like outside the door they face?
Well, that could get interesting because the Japanese may have cultural issues with essentially firing a projectile launcher off of their robot arm.
Well, it's always worth a discussion,
Exactly, it's definitely worth the discussion. It's not technically impossible.
Right. Okay. Well, I mean, that's the only thing that is a true block, right? Is if it's technically impossible. That's the only one that makes it hard. The rest of them are just convincing the right people that it should be done, and so those are things that physics won't prevent you from doing.
Right.
So.
Well, looks like we're about out of time.
Yeah.
But we should head down and see where we're going to go next.
Yep.
Music of
Thank you,
Science
guys.
is downstairs in Pod 1, and Nuclear Rockets is up here in Pod 3. So Pod 3 is right next over here.
Yeah.
Nuclear
Oh,
rockets.
no, Pod 3 is across the hall.
So music is downstairs.
Music of Science is downstairs.
Hey, so Justin,
Music of Science.
Just-
oh my God.
Oh, yeah.
I don't know which one's which.
I'm happy to fund hardware
Uh-huh.
because I think that's relatively cheap. If you can get me a launch.